Hello everyone, welcome back to another video. Today we're going to be covering GPS approaches. We're going to cover what are they, how do you fly one, and then there's going to be a video example at the end. This is for entertainment purposes only. So what is a GPS approach then? So a GPS approach is an approach that relies solely on GPS waypoints rather than ground-based equipment, such as an ILS approach. So these can be installed more places around the world as they're more convenient to install. So they can be installed in places which have high terrain. So RNAV then mandates a certain level of equipment and assumes you have a 95% chance of maintaining a stated level of navigation accuracy. Whereas RNP, which is required navigation performance, is the same as the above. However, it includes onboard monitoring and crew alerting. So basically, you know how close you are to your track, and it alerts you if you're not. So that's why RNP is used during the approaches. And you can have different levels of RNP. So as you go to the en route section, you have like a higher lateral standard. So it could be 5 nautical miles you have to maintain left or right of track. Whereas when you come down to the approach, it comes down to 0.3 of a nautical mile. So it really depends on where you are, what the actual accuracy required is. So we can pair a GPS approach with something called SBAS or a wide area augmentation system. So these are both space-based augmentation systems and are usually launched by regions of the world. So for example, America uses the WAS system, whilst Europe uses EGNOS. So each one of these allow more types of approaches. Now it is important to know that the UK does not have EGNOS anymore. So it doesn't have SBAS, which means the UK can't do a number of these approaches. However, you've got a number of approaches which you might spot on a chart, and we're going to go through all the different types of RNP approaches today. So starting with the lowest possible RNP approach minima. So we start with a circling approach, also known as a circle to land. And you'll notice this on the bottom right of the chart here, and it gives you a number of different minimum descent altitudes. Now all this requires is a GNSS approach, and then you will make a circle to land on another runway. You can watch my video on that shortly coming out soon. Then you have the LNAV approach, which is another 2D approach, which uses a minimum descent altitude again, and all you require for this is GNSS. And with this one, the reason why the minimas are a lot higher, so you see on this chart it says the LNAV CDFA, continuous descent for final approach. That is the LNAV approach, because this one doesn't have any vertical guidance. It simply just tells you how laterally far you're off track. So this is the main one you will use in the UK unless you have some additional aircraft equipment, which we will discuss in a minute. And then we have the LNAV plus V approach. Now you won't ever notice this on a chart because it doesn't exist on a chart. It only exists in the aircraft. So when you're flying your G1000, you might notice you have an LNAV plus V approach when you go to select your procedure. Now again, this uses an MDA. However, it does have an advisory vertical guidance, and this is aircraft dependent, so not all aircraft have it and not all approaches have it, but does have an advisory vertical guidance. Now it is important to note that the minimums are the same as the LNAV approach. You can't just follow the vertical guidance blindly, because if you continue below minimum without having visual contact with the runway, your obstacle clearance is not assured. And it's also breaking the rules. And then the last of the 2D approaches, we have a localizer performance, LP approaches. Now these won't be available in the UK as we don't have SBAS, but other points around the world you might find an LP approach which also uses an MDA. So this again is a 2D approach because it doesn't have vertical guidance and is usually used in places with either high obstacles or high terrain. And then we move on to our 3D approaches. So one you may notice on this chart, as well as other charts around the UK and the world, is an LNAV/VNAV approach. Now this is a 3D approach because it does have vertical guidance, and the minimums for this is a decision altitude/decision height. Now the requirements for this are either a GNSS standard, and a Barrow VNAV. But that is aircraft dependent, and not all aircraft have it. So something like a 737 might have it, but it's important you check what your aircraft is equipped with before flying this approach. And then, or you could have SBAS, one of the two. Okay. But generally, you need to check what your aircraft has before flying this approach. And the minimums can be lower or they can be the same, as you can see in this example at Cambridge. And then the final and most accurate 3D approach is a LPV, which is a localizer performance with vertical guidance, which uses decision altitude as the minimums and requires both GNSS and SBAS. This can have the lowest minimums of all of them. We can go much lower to the ground. However, this is not available in the UK. So we spoke about earlier about the how precise is an RNP. So you can see here this kind of judges how accurate an RNP has to be. So en route it can be 2 nautical miles, it can be 5 nautical miles, it could be 10. As you get closer to the approach, you have to be within 1 nautical mile of your track, and then on the final approach segment you have to be 0.3 of a nautical mile. So you might recognise this diagram. As it is a non-precision approach, we have to fly it like this. Now again, it depends on your aircraft, but generally 0.5 nautical miles before the descent point, we reduce our power to slow the aircraft down. At 0.1 nautical miles before the descent point, I'm going to set my flaps at approach and set my rate of descent. Throughout the approach, I'm going to be checking my altitude versus chart readout. So 3 miles, this altitude. Then we're going to call 100 to go, start looking up, and then at minimums we will either go no contact going round or visual continue. So the RNP approach maintenance. You need to maintain a high scan rate. There's no glide slope indication. Sometimes there might be a vertical guidance, advisory guidance, as we said. So again, fast eyes, slow hands. Fly the attitude and rate of descent and reference the altitude to the chart. Okay, and make corrections as required to maintain the track and profile. And just look at the attitude indicator, make small adjustments, 1 degree up and down, very small. Again, slow hands. And we're just going to wait for things to settle. And there's no need to get on profile by the next advisory altitude. We don't want to chase things. And then once we're back on final approach track and altitude, adjust the altitude to maintain. And as we mentioned earlier, in the UK, you can't use the 3D elements of an RNP approach unless you have the barometric VNAV on some aircraft, so we could use a LNAV/VNAV approach. And then you can see in the orange box, this is where we would locate the altitude adjustments. So now we're going to go over to the aircraft so you can see how to fly an RNP approach. And welcome to the air, guys. We are currently cruising at 3,000 feet above Cambridge. We're just about to set up for the RNP approach runway 23, so please feel free to get your chart out to follow along. So it's the Cambridge Echo Golf Sierra Charlie runway 23 RNP approach. So shortly we're going to be setting up the approach equipment. So we don't need any sort of radio nav aids in terms of like ILS or DME or anything like that. That's all provided by the GPS. Some airports do require navigation aids such as an ADF for the go around, as that's where the hold is at Cambridge. So we'll set up the ADF here. So we need to set up the 332.5 Cambridge NDB, as you can see on the chart. So we're going to go onto the ADF box on the G1000. We're going to tune that in and identify it. So we're just going to go across to the right hand side, fill in the numbers, and then display it as well. So you can see the ADF there, and then we're identifying it. Putting the timer back up. So now we're going to go over to the G1000 and set up the actual RNP approach itself. So we need to come to the flight plan page and scroll down and put in our destination of Echo Golf Sierra Charlie and select the runway. We're then going to come out of that, click enter, and then press procedure. We'll then select the approach. So at this point you can see there's a number of different approaches. We're going to set the RNAV 23 via TIGPO. and we're going to check that's all correct. So it should be TIBCO Sierra Charlie 23 India and then Sierra Charlie 23 Foxtrot. And then we're going to set our barrow minimum. So we're doing the LNAV CDFA, so that's 460 feet plus 50 feet as it's a MDA. So our MDA is 510 for today. So we're just going to bug that in the window there. Once we've done that, we're going to click our load on the procedure once we're happy with everything in there, and then that will load it into the system. Because once we activate it, it will route us direct. So when we're ready, and once we've been clear, we click Activate Approach, and you can see here it's routing us to the initial approach fix of TIBCO. So now we are going to be routing direct TIBCO at altitude 3,000 feet. So we're going to bug a heading to incept that, and then we're going to bring up the flight plan page to make sure that we are incepting it correctly. So now the video is going to speed up a bit, just to take you through the approach. To that, we will reduce the power and slow down, and then at 0.1 we put our flaps down to maintain the 3-degree glide path. We've got 7 knots of wind, so that means it's going to be 83 knots, which means it's going to be about 450 feet per minute rate. Okay, so coming up to 0.5 now. Reducing to about 30% power. We're maintaining the altitude, waiting for 0.1. And we're going to set down 3-degree glide path. And we're simply just going to make the natural deviation. FatSky 01, final approach fix. And then ATC will often tell you to report that specific DV. So we want to maintain that 450 feet descent rate. So at 4 miles from touchdown, 1360 feet. Miles 1360, we're about 50 feet too high at the moment, so we're just going to reduce that power a bit and keep that descent rate going down. 3 miles 1040. Miles 1040 checked. Okay, so we can bring that back to about 500 feet per minute, 450. So we're at 85 knots, so yeah, about 500, 450. Work nicely. 450 probably. Okay, 2 miles 720. Miles 720. Slightly low. Next one will be a missed approach point. So bringing it down now, 450 feet per minute. Above. We are visual. Approaching minimums now.
500.
Minimums. Visual continuing. Okay, we're at 500 feet. Speed check flaps to landing now. I'm simply just maintaining this approach now. Looking for that final approach speed, which will start coming back now. A bit more power required, so it's putting a bit low. Okay, runway clear, gear down. Flaps set, approach stable. And that, ladies and gentlemen, is how you fly a RNP approach to the LNAV minimums. I really hope you guys enjoyed today's video, and if you did like it, please do feel free to drop a like and a subscribe. It does really help out the channel, and please feel free to check out one of my other videos. Safe flying, my friends.